Welcome to December 28th LeetCode Challenge. Middle of the linked list. Given the head of a singularly linked list, return the middle node of a singularly linked list. There are two middle nodes. If there are two middle nodes, return the second middle node. So, for example, you have a linked list such as this. For example, number 1, 1 points to 2, 2 points to 3, points to 4, points to 5. The middle of the linked list would be number 3 here, node number 3. You just return that, and then whatever comes afterwards, right? So it'll be 3, 4, 5. So the middle of the linked list is node 3. Then you just return anything after that. This is giving you the second prompt here. If there's two middle nodes here, give the second one. So basically, return 4 will be the second middle node. Therefore, you return anything after 4, right? That's pretty much it. Constraints is the value of the nodes themselves range between 1 to 100, and the range, the size is also between 1 and 100. Alright, so initially I was thinking maybe, go through the list of the go through the number of nodes and then make the length of a list, the length of the node, the linked list, but turns out I don't really need to do that. So let's think of an approach here that will kind of, for instance, say you have two pointers. You point them here, all the same pointer, and then you move this one pointer, it's called a fast pointer, and then you move it twice ahead, and you move a slow pointer, which moves one ahead. So every time you move, you will have two pointers that point to basically, you have a slow pointer moves one step forward and a fast pointer moves two steps forward. And when you reach the end, the slow pointer happens to be in the middle of the linked list. Therefore, you return the slow pointer. So that's pretty much it. The solution itself, the approach I should say, is called the fast pointer slow pointer approach. Which is something I didn't know how to name for, but I just figured out it had one right now. So I'll describe it, and then so let's first define a pointer. It's called slow pointer, fast pointer, and that's all equal to head. Right? So we have that so far. So while these exist, so fast pointer and fast pointer dot next, well, that's true. What we're gonna do is basically assign slow to be slow.next, and then we want to assign fast to fast.next. So it's easier to kind of code it out and describe it, and then we want to return slow. So basically, a slow pointer will move at a normal rate. So each time we go through this while loop, slow just gets assigned to the next pointer. However, fast pointer gets to point to the next two pointers. So that means in theory that every time the fast pointer moves once, every time the slow pointer moves once, the fast pointer moves double its speed. So by the end of it, if the fast pointer does not exist, or points to 0, or points to none, that means the slow pointer will be at the halfway point. And then it returns the slow, which is pointing to the pointer at the middle. Alright, and that's pretty much it. There you go. So this is a one-pass approach where it would take big time complexity of a big O of n, because at worst case we have to iterate through each node of the linked list. And yeah, that's pretty much it. Slow pointer, fast pointer, slow pointer technique approach. It's pretty neat. And that's it. Have a great day, guys.